Hey everybody, this is Alex Merced from alexmercedcoder.com, and in this video what I'm going to do is just kind of go over a couple different pieces of programming terminology. So what I'm going to do is I'm going to be using JavaScript, but these terms apply to any language, and you can take basically what I'm saying in this video and apply it to any language. So whether you're learning JavaScript or Java or Haskell, this all will still apply. Okay, so I'm going to create a new file. We'll just call this scratch.js, and I'll run a new terminal. And first thing I want to talk about is the difference between an expression and a statement. So a statement, okay, does not return a value. So for example, I can't do this. Const cheese equals if true cheese. Okay. See, it says expression expected, because an expression is a bit of code that's actually going to result in a value. So this if is a statement. What it does, it just says, hey, if this is true, it'll do whatever's in the curly brackets. It's not going to return. So in that case, there's nothing that this if will produce that I can then store in this variable. So this if is a statement, not an expression. So ifs can be statements or expressions depending on the language. So if you're using Scala, ifs can be used as expressions. They can actually return a value, which is pretty cool. In JavaScript, ifs are just statements. So in that case, if I wanted to use this if statement to set the value of cheese, what I'd have to do is be like, let cheese, and then do if true cheese equals Gouda. Okay, so that would be, because it's a statement, I can't assign this bit of code to a variable because it doesn't actually have any value. But within the code, I can then have side effects, which means I can alter things and change things. So statements are only valuable for their side effects, meaning the things that they change external to the statement. So this statement is changing the cheese variable, which exists outside of the statement. Okay? While an expression returns a value. Okay, luckily in JavaScript there is a version of an if that is an expression. It's referred to as the ternary operator. Okay, so in that case, basically, if I were to create, like, let's say const cheese2, the ternary operator does this. I could say true as my expression, like, what am I? Hey, is this true or false? And then I can be like Gouda not cheese. Okay, and see this if statement saying, hey, if this is true, return this. If this is not true, return this. So this expression, so this actually results in one value. When this is said and done, this value will be returned and can then be saved in the variable. So this expression is, well, it's an expression. It returns a value. So again, so this was a statement, so it's a code that runs, and I could alter things external to that statement, but it itself does not produce any value, while an expression is a bit of code that will be reduced to a value. So for example, an expression can be as simple as like 1 plus 1. So 1 is an expression. 1 returns 1. 1 plus 1 is an expression. It's going to return 2. Okay, so these are all expressions. They all give back a value that I can then assign to a variable. Statements cannot be assigned to a variable. So that's a big difference. And the reason why that's important is if you ever do a language, especially functional programming languages, where generally everything's an expression. So if you use Scala, if statements are expressions, while loops are expressions, all these things can actually return a value that you can then assign to a variable, which I think is actually really super cool. Okay. The other thing I want to talk about is how we talk about functions. Okay, functions have a signature. So a function signature is just a description of what the function does. So for example, if I were to say, hey, this function, what it is, it's a function that takes in a number. Okay, so it takes in a number and returns a number. Okay, that's a signature. It's not the actual function. Okay, this could describe many functions. Okay, it's a function signature, meaning a function that takes in a number as a parameter that and they and then that function then returns a number. So the signature is a description of the high level of what the function is, which is really oftentimes what we care about when reading documentation. I don't necessarily care about what's called the implementation. The implementation is how the function actually works. So if I were to implement a function that matches this signature, okay, I would say, okay, const add1 equals x plus 1. Okay, and assuming that I give this a number, add 1, 2, see I'm passing in a number, so it's receiving a number, that's the parameter, and it's going to return 2 plus 1, which is a number, so it's a function that takes in a number and returns a number. So this is the implementation, the actual function, the actual details of how this function works and achieves the result, but it is an implementation of this signature. Okay, so oftentimes when I'm reading documentation, I'm not looking to read the implementation. Okay, because the whole point of using libraries is to not have to think through how things are implemented. So I just want to know what the signatures of functions are. Like I want to know, hey, if I use this function, what do I need to give the function and what will it give me back? So oftentimes when you're reading documentation, you'll see the signature of a function, not the implementation. But those, again, those two words, the signature being sort of this basic descriptor, takes in this, gives back this. How it does that, I don't care. The how is the implementation. Okay, so implementing is when I actually fill in the details. The signature is when I'm giving sort of like the high level overview. Okay, and again, so you'll see that terminology a lot in all languages when people talk about functions. Like, is this a function signature? The function's signature is this in that sort of high level description, but its implementation is this. These are the details of how the function actually achieves that description of taking these inputs and sending out these outputs. Okay, so hopefully you guys found that useful. If you liked it, leave a comment, like the video, subscribe. I'll see you all later, and have a good one.